Alright, we're looking at area, and in the previous video we were approximating the area under the curve, and we were using the right endpoints. But this time we're going to be using the left endpoints. So let's take a picture, or look at a picture. Let me write the function up here that we're looking at. F of x is equal to negative x squared plus 6, and we're on the interval between 0 and 2. Let's draw a picture, or at least attempt to draw a picture. The reason that this is so difficult, I'm drawing on a sketch pad that's got an extremely smooth surface. We're between 0 and 2, and we're wanting to find the area under this curve. Now we're going to be using the right endpoints this time, and the right endpoints means it's going to be the right part of the triangle. And like I said, I'm going to attempt, this is not going to be to scale here, but at least you'll get the idea. We're going to be dividing this into 5 pieces just like we did in the previous one. At least that's the one we're going to work with, and then of course I wrote a program to do an n number of pieces. But if we divided this into 5 pieces, we would end up with 2/5 would be the width of this rectangle, and of course the height of the rectangle is going to end up being the f of x, or I'm sorry, f of 2/5 I minus 2/5. I just about forgot what the heck I was doing there. And the reason this time there's a minus here, let's look at this one here, for example. If my eyes are going to be 1, 2, 3, 4, and 5. If I come out to the second one, okay, this is what is coming in contact with the curve. So if I come out to here, yeah, the second rectangle, if I plug 2 in for I, right, so this is 2/5 and then plus 2/5. But what's happening here is I'm going back and I'm subtracting off a 2/5. So remember, if I were equal to 1, you would be here. Okay, if I was equal 1, then we would be here at 2/5, because I would plug 1 in right here, and 1 times 2/5 is 2/5. But then if I subtract off a 2/5, then we're just back to here. See? Okay? And that's how we're going to get our left endpoints. That's how we're going to get the left endpoints. And of course, this is not divided into 5 pieces, but anyway, you get the idea right here. So you can see that when we divide this into 5 pieces, notice that this part of the rectangle here is outside that we're also including in our area. So our area is going to be greater than the actual theoretical value. Okay, the area, once we sum up all of our rectangles, it will be greater than the actual theoretical value of the area. All right. So just like we did in the previous problem, we are going to take f of 2/5 I minus 2/5. So that's going to be the height of the rectangle, and the width is 2/5, as you can see here. And we'll be summing that up from I equals 1 to 5. That's a 1 right there. I did pledge to try to write a whole lot neater. I'm trying. So how do we decipher this? Well, we write 2/5 I minus 2/5. Actually, I'm going to factor that 2/5 out if you don't mind. Let's factor that out. And then we have I minus, or that's an I, minus 1. It's quantity squared, and that means all of this right here. And then remember we had the minus sign out here and then the plus 6, and let's put a parentheses around this, and then of course we've got the 2/5. And also we need to write our summation sign out here. Remember we're going from 1 to 5 out here. So as you can see, this is the F of stuff here. We'll call that stuff, right? So that's all of this piece right here, and then of course the 2/5 outside. Now remember, we use the formulas like we did in the previous problem to actually work this out if we were going to work this out by hand. Of course, we wouldn't want to have to sum all this stuff up. Now we could we want to use the formula. I mean, that's the ideal thing to use. It's n times n plus 1 times 2n plus 1. I'm trying to actually remember, what was that formula? Yeah, n times n plus 1 times 2 to the n, 2 times n plus 1 over 6. That's the formula we want to use, and something happened down here. There we go. We can actually, let's see, rewrite this. This becomes square here, and then of course you distribute the 2/5 across. But you know what? I think I'll let you work that out. If you watch the previous, you should be able to actually get this one. But I wrote, just to give you an idea, this should all equal, this is going to all equal 252 over 25. So you should try to get that. Now let's look if, for example, if we divided it into 6/7, 8/9, 10ths. All right. Oh, and by the way, also take the limit as n goes to infinity. So hopefully if you watched the previous on how to do right endpoints, apply that to this problem here. All right. I'm going to bring up my Python. Okay, this is not supposed to be a class about Python, but I thought I would throw it in there anyhow. So this was the right endpoint. This was the script here for the right endpoint, and then I wrote a function down here for the left endpoint. Let me drag this down. So here's the one for the left endpoint. This R right here is going to represent, for example, we're going to plug 5 into our function, and we should get out like 10.08. That's going to be approximately the 252 over 25. And this is the actual sum right here. So I'm doing this a little bit different than I did in the previous problem where I actually completely worked it out. This one we're actually going to be summing it up depending on what I say we're going to sum it to. This is the Python shell here. So I plugged in 5, and of course we got 10.08, and then I plugged in 1,000. In other words, we're dividing it up into 1,000 rectangles. Okay, and we're approaching that 9.33. And remember, that was the actual theoretical value. So when we did the left endpoint, or when we did the right endpoint, it was a little bit less. When we did the left endpoint, it's going to be a little bit